Hey Benold Eagles, we're going to simplify radical expressions today. This is a continuation really of what we have done so far together in class. Specifically, this will include multiplying some radicals together, perhaps dividing radicals, doing something with a denominator to meet certain requirements. So let's go ahead and get started. So your title 6.2, Simplifying Radical Expressions. And for the first one, we're looking at the square root of 5 times the square root of 10. Now, we already understand that to simplify these, it involves breaking down into factors to see what we can pull out and that sort of thing. So quite honestly, while you can start by calling this the square root of 50 and move on, there's really no need. Instead, the square root of 5, the 5 is already prime, so I'm good with that as is. Square root of 10, we know the way to get 10 comes from 2 times 5. So if we look at this, I have a 5 here and I have a 5 here, so that means I get to pull out a 5, and the 2 is stuck. So the square root of 5 times 5 is just a 5 on the outside. The square root of 2, there's nothing I was able to do with, so it stayed. If we look at the next one, we have the square root of 6 times the square root of 8. Okay, so for your 6, we know that that breaks into a 2 times 3. For the 8, I'm going to write that it breaks up into a 2 times 4 because 4 is a perfect square. I can already take square root of 4. And the 2, that's the other factor that we would need. 2 times 4 is 8. So then when we see what we can pull out, I have a 2 here and I have a 2 here. The square root of 2 times 2 is a 2 on the outside. So that part is done. The square root of 4 is 2. So that's times another 2 outside. That part is done. The square root of 3, can't do anything about that. So the 3 is stuck. 2 times 2 will give you a 4. So we are left with 4 square root of 3. So could you have made this into square root of 48 and then gone from there? Yes. But going from there means breaking it up into factors, so feel free to break up into factors from the beginning. Number 3. Let's simplify the square root of 32. We have an r squared, a k to the 4th, and then a t to the 5th. All right, first I need to deal with my square root of 32. I'm going to go off to the side to do a little bit of that. A little touch of that upside down division. Now, yes, 2 goes into 32, but I also know that the perfect square of 4 will go into 32. So I'm going to make use of that because 4 times 8 is 32. Now, likewise, the perfect square of 4 will go into 8. It'll go 2 times. So when I'm dealing with my square root of 32, I'm using these couple of 4s. So actually, since I have the square root of 4 times 4, that means on the outside, I get to pull out a 4. But I am left, from my 32, I'm left with this 2 that's stuck. The r squared, that's even, so I'm going to be able to work with that perfectly. K to the 4th, that exponent's even, I'm going to be able to work with that perfectly. But that t to the 5th, t to the 5th is equal to t to the 4th times t to the 1st. Because 4 plus 1 will give you 5. And I need to do it that way because my square root of t to the 4th, my 4 is even, I know I'm going to be able to call that t squared. So when we pull out what we still can, my 4 is outside still. Square root of r squared is equal to r. Square root of k to the 4th is equal to k squared. Square root of t to the 4th is equal to t squared. Then I've used my r, my k, my t. That square root of 2, remember, was stuck. And the square root of just this t to the 1st is a plain old t, and that's as far as that we can go. Okay, let's look at the next one. Square root of 6y, all under the radical. And then that's over the square root of 12. First, we need to recognize that if we have the square root of something over the square root of something, we can call it one great big square root of our fraction. Okay. Before we do anything else, you have a fraction that you can reduce. 6 over 12 reduces to 1/2. 6 divided by 6 is 1. 12 divided by 6 is 2. So we are looking at the square root of y over 2. Well, I have an issue here. My issue here is that the square root of y over 2, which is the same as the square root of y over a square root of 2, gives me a radical in the denominator. We don't want that. We need to do something called rationalize the denominator. We need to do something to where we will no longer have a square root in the denominator. Well, here's our process. I have a square root of 2 in the denominator. That's where I have my issue. Think of what the square root of 2 times square root of 2 is. Square root of 2 times square root of 2, which is square root of 4, is a plain old whole number of 2. That's good. I want that. But you know I can't just multiply the denominator by square root of 2 and call that it. Nope, I have to multiply by a fancy form of 1. Square root of 2 over square root of 2 is equal to 1. So I'm allowed to take this fraction times 1. And I want to because it will make it to where I no longer have a square root in the denominator. Okay, so what we do with it, square root of y times square root of 2, to make that look a little bit better, I will call that a square root of 2y. And then down in the denominator, square root of 2 times square root of 2 is equal to 2. That's as far as I can go. This 2 is stuck under the radical. This 2 is outside of the radical. There's nothing I can do with those guys. Those are totally different numbers. This is about 1.4 something, and this is 2. So I'm stuck. All right. Make sure you pause and take a look at what we've done so far. Then we're going to continue on with the next problem. I want you to pause the video, complete number 5, and then we'll check. All right, check your work. Square root of 56. Personally, I broke 56. 2 goes into 56 28 times. Then I noticed, well, the perfect square of 4 goes into 28 7 times. So I chose 2 times 4 times 7 for my 56. You could choose another combination so long as you end up with, notice the square root of 4 gives us a 2 outside, and 2 times 7 gets you a 14 on the inside. Even if you said 2 times 2 times 2 times your 7, whatever is going to get you a 2 outside and a 14 inside. The square root of x is stuck. Your square root of y to the 10th, half of y to the 10th is y to the 5th. Square root of z to the 5th. That's not even. Z to the 5th is equivalent to z to the 4th times z. Square root of z to the 4th is z squared. Square root of my z is stuck. One thing that I have not addressed is the fact that this part, this z squared, if you plug in any number you want for z, that's going to end up being positive. But over here, this y to the 5th, well, if you plug in certain numbers, if you plug in negative numbers, you would get back a negative answer, and yet that's not okay. So technically, we need to call this the absolute value of z to the 5th. In all honesty, I'm not going to be pushing that. We're going to assume our variables are positive. but I need for you to at least see a little bit of what we're doing. This also applies if we scooch back to number 3. This also applies right here. When I pulled out my R, the R had to be positive for all this to truly work out. All right, so make sure you have number 5, and then we're going to do 6. Okay, so let's take a look at number 6. We have the square root of 27 over m to the 5th. I need you to recognize 27 as 9 times 3. So I've got a square root of 9 times 3 going on. M to the 5th, that's an odd exponent. I'm going to make use of that as an m to the 4th times an m, because 4 plus the assumed 1 gives us a 5. What that gives us? Square root of 9 is 3. Done. Square root of this 3 is stuck. Over. Square root of m to the 4th is perfectly good as a m squared. The square root of m is stuck. Oh, remember I said I did not like to have radicals in the denominator. We can't do that. We have to do things called rationalizing denominators. This square root of m is the whole issue. This is my decision maker. So, we know that the square root of m times square root of m is equal to a plain old m. That's good. But I can't just multiply a plain old square root of m. I've got to make it in a form of 1. So what that gives me is up in the numerator, this 3 is outside, but inside I have a square root of 3 square root of m. I'm stuck with a square root of 3m. Over here on the outside, m squared I'm going to bring down. Square root of m times square root of m is equal to m. Then simplify. 3 square root of 3m over m to the 3rd. All right, our next one is when our denominator is even more complicated. Notice I have subtraction and a radical in my denominator. Just multiplying by square root of 7 is not going to be good enough, because if I multiply this denominator by square root of 7, I'm given 3 square root of 7 minus 7. That's not good. Instead, we're going to work with something called the conjugate, where since I have a 3 minus square root of 7, the conjugate is 3 plus square root of 7. And you know I'm going to do the numerator by the same thing. Now, your numerators normally, just normal multiplication. 7 times 3 is 21, plus 7 times square root of 7 is a 7 square root of 7. Okay, that part's fine. But what in the world about the denominators? Why in the world did I do this thing? 3 times 3 is 9. Now think about the middle term. 3 times square root of 7 is a 3 square root of 7, but square root of 7 times 3, negative square root of 7 times 3, gives me a minus 3 square root of 7. And negative square root of 7 times positive square root of 7, negative times a positive is a negative, square root of 7 times square root of 7 is 7. Normal distributive property. Now think of what that gives me. 21 plus 7 square root of 7 over 9 minus 7 is 2. 3 square root of 7 minus 3 square root of 7 cancels out. That's why we use this thing called the conjugate. I want you to follow that pattern exactly to do this one, and I will give you the hint first that it's going to be 5 minus square root of 11 that you multiply numerator denominator by. Pause the video, work it out, and then we'll check. So check your work. Notice, by the way, 30, 6, and 14 are all divisible by 2. Kind of showed that here. So I did a final reducing of the fraction. So make sure you make note of that as you deal with any corrections, and I'll see you in class tomorrow.